Hello everyone, and welcome to the Smart Curve lesson on climate. If you will start the PowerPoint here. Now, I think we understand that if you look at the Earth, we see a great diversity of weather. Some parts of the Earth are very hot and dry. Some parts are very wet. Some places are very cold. Um, the purpose of this lesson is to help you understand why the Earth has such a great diversity of climate, so many different types of climate. So let's go ahead and get started. The first factor we're going to look at here on slide 3 is latitude. Now, when you look at a map of the Earth, latitude, these are the lines that go across the map, sort of like the rungs of a ladder. That's a way you can remember latitude, because they are like the rungs of a ladder. On slide 3, we see as latitude increases, the intensity of solar energy decreases. Now you can see this if you're on slide 4. We have a picture of the globe. You can see that the equator is that line going around the center of the Earth, and the latitude there is 0. So here on slide 4, you can see that as latitude increases, the intensity of solar energy decreases. So when the latitude is 0, we have very high intensity solar energy. And when latitude is very high, like when we're near the North Pole or the South Pole, we have very low intensity solar energy. From that same picture, we can see a tropical zone is that area between 23.5 degrees north, which we call the Tropic of Cancer, and 23.5 degrees south, which we call the Tropic of Capricorn. Both of those are visible on that picture of the Earth. The sun's rays are most intense, and the temperatures are always warm. As we move to the north and to the south, away from the equator, and we leave the tropics, we next enter the temperate zones. These are the areas between 23.5 and 66.5 degrees. Here, you can see the sun's rays strike the Earth at a smaller, let me start over. The sun's rays strike the Earth at a smaller angle, and so we get less intense solar rays. We get a lower intensity of sunlight, so we tend to find cooler temperatures. On slide 5, I want to look at the climate data for two different cities, Phoenix, Arizona, and Flagstaff, Arizona. These are two cities in the American Southwest. And the map in the background shows the location. The red dot is Phoenix, and the blue dot is Flagstaff. Now the red lines at the top of the image show you the average temperature. Notice that for both cities, the months of July and August are the hottest around, and the months of December, January, and February are the coolest. At the bottom of the image, we can see the precipitation. Now, precipitation means rain or snow. Notice in for both cities, in Phoenix and Flagstaff, the months of May and July are the driest. That is, they have the least precipitation, the least rain. And the months of July and August are the wettest. They have the most precipitation. So notice a couple of things. Notice first that for both cities, the hottest months are also the wettest months. So the months with the highest temperature are also the months with the most rain. However, despite these similarities, I also want you to notice the big differences between these two cities. With temperature, we can see that all year round, the temperature in Phoenix is much higher. The weather is always much hotter in Phoenix than it is in Flagstaff. We can also see that Flagstaff gets much higher precipitation than Phoenix. So Phoenix is hotter and drier. Flagstaff is cooler and wetter. But those two cities are very close to one another. They're not very far apart. So it's probably not a difference in latitude that's causing this difference. So what this map and these two graphs show us is that there are other factors. There are factors other than latitude that can affect climate. And today we're going to look at some of those factors. Now, on slide 6, we're going to go down a list here. We've got a number of factors. The first one, latitude. We already talked about tropical zones and temperate zones. Now, if you go back and look at that picture of the Earth on slide 3, you can see the very tips of the Earth, the top and the bottom, with latitude above 66.5 degrees, are known as the polar zones. They're at the very top, the very far north and the very far south. And these are the areas where the sun's rays strike the Earth at a very small angle. So there is almost no direct sunlight. So they get less intense sunlight, and so they are much colder. Now, that's latitude. But as we saw in our last slide, latitude is not the only factor. Because remember, Phoenix and Flagstaff, they have a very similar latitude, but very different climate, very different temperatures, very different amounts of precipitation. So what are some of those other factors? We'll see the next one in the list, elevation. The higher the elevation is, usually the colder the climate. We know here in Thailand, if you go up to Chiang Mai, it's much cooler than Bangkok. And one of the reasons for that is Chiang Mai is in the mountains, so it's at a higher elevation. So the temperatures tend to be cooler than in low areas. Now the third one is one I want to look at. Topography. Topographic features such as mountains, play an important role in the amount of precipitation that falls over an area. We're going to take a look at this on the next slide. Here we can see one of the major effects of topography on climate, and this effect is called the rain-shadow effect. You can see in this picture we have a very steep mountain range in the middle. Now from the left we have that blue arrow that represents cool, wet air. Now that's air that's going to bring a lot of rain. Remember in our unit on weather when we learned about warm fronts and cold fronts, this mass of cool, wet air is going to hit that mountain range, and it's going to start to rise where it's going to become even cooler and condense. So that air that's very wet is going to bring a lot of rain. As that air rises and comes over the mountains, well, all of that water vapor has already condensed and fallen as rain. So when that air comes over the mountains, it's very dry. There's no water vapor left in the air. So as it comes down the mountains, it becomes warmer and warmer, so that air on the other side of the mountain, on the right side, is going to be very warm and dry. And this area we call the leeward side, or the rain shadow. So that cool, wet air comes up, the rain falls, and then warm, dry air comes down the other side. The rain shadow effect. And this is seen. We see this in many parts of the world. We see this in Africa, in Morocco, where there's an area along the coast that gets a lot of rain, but once you come over the mountains, it's very hot and dry. That's the Sahara Desert. We see this in parts of India, especially southern India, when cool, wet air comes in from the Indian Ocean, but it hits that mountain range in southern India, and on the other side of the mountains, it's very warm and dry. We also see this in Arizona. Look at Flagstaff and Phoenix. That cool, wet air that comes down from the north, from the Pacific Northwest and from Canada. Remember, we learned about this in our lesson on weather patterns. Those cold fronts come down and they bring rain with them. But that rain only falls on the windward side of the mountains. By the time that air comes over the mountains to go down to Phoenix, it's already very hot and very dry. So in the example we looked at back on slide 5, you can imagine Flagstaff being on the left here and Phoenix being on the right. So even though the cities look very close on a map, because they're on opposite sides of the mountain, their weather is very, very different. All right, let's move on. Another factor, bodies of water, oceans and seas. Large bodies of water such as lakes and oceans have an important effect on the temperature of an area because the temperature of the water influences the temperature of the air above it. So, warm water can warm the air above it. This is seen, a good example of this is Western Europe. Now, Western Europe, like France, Spain, and Italy, are much warmer than Eastern Europe, the areas like the Czech Republic and Poland. Now, the reason that they have that warm weather, part of the reason, is because they have warm water coming up from the southern part of the Atlantic Ocean. And that's a stream of warm water that we call the Gulf Stream. If you look at a map of the world, you can imagine this area down in the Gulf of Mexico, between the United States and Mexico, very close to the equator, that tropical Gulf. So the water gets a lot of direct sunlight. It's very warm. That water travels north along the east coast of the United States and then across the Atlantic Ocean to Europe. So that warm water is carried all the way across the Atlantic, and it helps to warm the air above it. So that's why France and Portugal and Spain have much warmer weather than the areas in Western Europe. The next factor, still here on slide 8, atmospheric circulation. Global winds are another factor that influences climate because they distribute heat and moisture around the earth. So just like the currents of water, the currents of air do the same thing, can bring heat energy around the planet. Next, vegetation. Vegetation can affect both temperature and precipitation patterns in an area. And we're going to take a closer look at this in the coming slides. So we have many different factors that can affect climate. Everything from latitude, where we learned that the areas of very low latitude near the equator get direct sunlight, so they are warmer. Areas of high latitude near the north and south poles get very little direct sunlight, so they're colder. We also looked at altitude. Very high areas high in the mountains tend to be colder than areas that are very low near sea level. We also looked at the effect that ocean currents and winds can play. So we have a lot of different factors and therefore many different types of climate on the planet. So scientists who study weather, they put different types of weather, different areas of the world, into different classes of weather. And we call this class system the Köppen system. It's a way to describe the climate in different parts of the world by temperature and precipitation and seasons. And we're going to look at these different types of climate under the Köppen system right now. Moving on slide 11. The first type of climate we're going to look at are the humid tropical climates, that humid, wet climate. Humid tropical climates have no winters. They're close to the equator, so there's never actually a winter. The months have a mean temperature of about 18 degrees Celsius. Yes, in tropical areas, there's very little change in temperature compared to temperate regions. We already looked at the tropical and temperate zones of the planet. Not only are tropical regions warmer, but there's very little variation, where in the tropics we might have variation like this between the warmest months and the coldest months. In temperate regions we might see a change more like this, with higher highs and lower lows. Alright, so every climate has a mean temperature Every month has a mean temperature about 18 degrees. The amount of precipitation can exceed 200 centimeters per year. So they're warm, they have little variation, and they're very wet. Wet tropical climates, high temperatures, and very much annual precipitation. We can see a good example of this on slide 12, a picture of a rainforest in Malaysia. In Malaysia, it rains all year round. It's not like Thailand where we have a dry season. The rain in many parts of Malaysia, it rains all year round, and it's very warm all year round. So we get a tropical rainforest. Moving on, continuing with our humid tropical climates. Tropical wet and tropical dry climates are climates that transition between the wet tropics and the subtropical steppes. If you want to look at an example, there's an example of tropical dry. On the next slide, number 14, we see an African savanna. Notice the difference there between the rainforest on slide 12 and this grassland on slide 14. Now, both of these, the African savanna or the Malaysian rainforest, could both be very close to the equator. And in fact, both probably are very close to the equator. But it's hard to imagine two places on Earth more different than that rainforest on slide 12 and that savanna on slide 14. That's the difference between tropical wet and tropical dry. Moving on, as we move away from the equator, remember from our world map on slide 5, on slide 3, we saw the tropical areas near the equator. Outside of that, we have our temperate areas. These mid-latitude climates are areas with mild winters. Average temperature in the coldest months below 18 degrees but above -3. This is like where I'm from, in North Carolina, in the eastern United States. Our coldest month, we have temperatures between 18 and -3. But the hottest months get above this. Climates with severe winters have an average temperature in the coldest month that is below -3 degrees. If you go to the northern parts of the United States, north of my home, you find these colder temperatures, the severe winters. And we are going to talk about these different mid-latitude climates, why some areas have mild winters and why some temperate areas have very severe, very cold winters. Let's start by looking at a few of the different types of humid mid-latitude climates. On slide 16, we see first humid mid-latitude with mild winters. A humid subtropical climate is generally located on the eastern side of a continent, like my home in North Carolina. We're on the eastern side of the American continent. It's characterized by hot, sultry summers and cool winters. Yeah, in my home, our summers were very hot and very humid, and our winters were cool, but not terribly cold. A marine west coast climate is found on the windward coasts from latitudes 40 to 65 and is dominated by maritime air masses. Winters are mild and the summers are cool. So remember our picture from slide 7. That windward side, the winds come in from the wet, bringing that wet, cold air. So that's the type of weather that we find on the marine west coast. And we're going to see an example of this in a couple of slides. But the next point to make, a dry summer tropical climate is a climate located on the west sides of the continents between 30 and 45. It is the only humid climate with a stronger winter precipitation maximum. Yeah, all right. Yeah, remember our dry summer subtropical climate. It's the only climate with a stronger winter precipitation maximum. Remember the example of Flagstaff back on slide 5. Flagstaff, we saw more precipitation in winter. Most parts of the earth get more precipitation, more rain in summer. But that dry summer tropical climate, subtropical climate, you get more precipitation in winter. We're going to look at 3 examples of this on the next slide. Slide 18, we see 3 different types of climate. The first, now notice, in all 3 of these pictures, the red line at the top of the image is our temperature. And those blue bars down at the bottom are our precipitation, the amount of rain and snow. So with that in mind, let's look at the climate in 3 different cities. The first city, Guangzhou, China, 23 degrees north latitude, so it's right on the edge of a tropical and temperate zone. And it's also right on the coast. And notice it's on the eastern side of the Asian continent. So a couple of things to know, just to keep in mind. Remember, we're right on the edge of tropical and temperate zones, and we're on the east side of the Asian continent. So notice we get our highest precipitation in summer. And notice that our precipitation peaks before the temperature peaks. Our highest precipitation, the highest rain, comes in June, but the highest temperatures come in August. So our precipitation peaks in the early summer, and our temperature peaks in late summer. The next one to look at, in the middle, Sitka, Alaska, 57 degrees north. So we are still in a temperate zone, but much farther north. We're almost to the polar region. Notice here that we're on the west side of the continent. We're on the windward side of the continent. So what's going to happen on that windward side? We'll notice that our high precipitation, we'll notice that our temperature, in this case, peaks before our precipitation. Our temperature, we get our highest temperatures in a late summer. So in that respect, it's very similar to Guangzhou. The temperature peaks in July and August. But in Sitka, in Alaska, the precipitation peaks after. So we get our highest precipitation in October, September, October, and November. Our summer, our spring and early summer is actually the driest time of the year. And that early fall moving into late fall is our wet time of the year. So in China, we get a very wet early summer before the temperature peaks. And in Alaska, we have our wet months in September and October after the temperature peaks. And then the final one, Cape Town in South Africa. Notice Cape Town is much drier than either Guangzhou or Sitka. Notice that there's much less variation, both in temperature and in precipitation. So notice that temperature peaks around January and February, and precipitation peaks around June and July. So three very, very different types of mid-latitude climates. Next, on slide 19, our humid mid-latitude climates with severe winters. All right. A subarctic climate is found north of the humid continental climate and south of polar climate. It is characterized by bitterly cold winters and short, cool summers. Places within this climate realm experience the highest annual temperature ranges on Earth. Now, these are going to be areas very different from the three cities we've looked at. Notice on our last slide, 18, when we looked at Guangzhou, Sitka, and Cape Town, these three cities have very different climates, or very different range in temperature, a very different range in precipitation, but they're all near the coast of a continent. Guangzhou, Sitka, and Cape Town, in fact, they're all right on the coast. They're all very close to an ocean. We're now going to look at climates that are in the middle of a continent, very far from an ocean. And we're going to look at that on the next slide. We're going to look at Chicago and Chicago, Illinois in the United States, and the town of Moose Factory, Ontario in Canada. Notice, compared to the cities on slide 18, compared to those cities on slide 18, we see a much bigger range in temperature. So notice, if a city like Guangzhou was in this range, these cities like Chicago and Moose Factory are going to be like this, with a much higher range in temperature. Also, notice there's much less change in precipitation. So compared to coastal areas, these mid-latitude climates in the middle of a continent, far from the oceans, they have much more variation in temperature and much less variation in rain, in snow, precipitation. So the temperature varies greatly, but precipitation is more flat. Next, dry climates. A dry climate is one in which the yearly precipitation is not as great as the potential loss of water by evaporation. These also known as desert areas. Next, polar climates. Polar climates are those in which the mean temperature of the warmest month is below 10 degrees. So even in the warmest times of year, the temperatures are below 10 degrees Celsius. You can see a perfect example on slide 23, an ice cap. That's a polar climate. It never gets above 10 degrees in an area like this. Slide 24, highland climates. We've already talked about the effects of mountains on climate. Highland climates are cooler and wetter than nearby areas at lower elevations. We looked at an example here in Thailand of Bangkok and Chiang Mai. We know that Chiang Mai is much cooler than Bangkok because it's higher up in the mountains. It has a much cooler climate than Bangkok. Other processes that affect climate change. Volcanoes. That first bullet point on slide 25. The presence of volcanic aerosols such as ash, dust, and sulfur in the air can increase the amount of solar radiation that is reflected back into outer space. This causes the lower atmosphere to cool. So all of this ash in the air almost acts like an umbrella. It blocks out the light, and it can make areas much cooler. Also, changes in ocean circulation can result in short-term climate fluctuations. Sometimes the current, we talked about ocean circulation, like the Gulf Stream. Well, sometimes these ocean currents can change because of changes in temperature. When we get these changes, we can see fluctuations in the climate. We're going to look at it, one example of each. First, an example of volcanic eruptions on slide 26. The eruption of Mount Pinatubo in the Philippines. Several years ago, well, I believe it was about 20 years ago, was the biggest eruption of Pinatubo. And all of that ash going into the atmosphere affected weather all around the world. So volcanic eruptions can affect weather. The next, the effect of El Nino. This is the second point that we talked about on slide 25. That ocean circulation. El Nino is a large area in the Pacific Ocean near the equator. When that area gets very hot, it can change the current in the Pacific, and it can affect weather all around the world. This picture shows an example of flooding caused by El Nino. Other processes. Solar activity. When the sun is most active, it contains dark blemishes called sunspots. Without going too much into that, it's caused by the rotation of the sun's magnetosphere. The sun, just like the Earth, has a north magnetic pole and a south magnetic pole, and that magnetic field will actually twist as the sun rotates. And so when that magnetic field twists more and more and more, we end up seeing these dark spots on the sun called sunspots. It's almost like a short circuit in the sun's magnetic field. But this can actually affect the weather here on Earth. The formation of sunspots appears to correspond with warm periods in Europe and North America. The motions of the Earth. Geographic changes in Earth's land and water bodies can cause changes in climate. Changes in the shape of Earth's orbit and the tilt of the Earth on its axis can also affect climates. The greenhouse effect. The greenhouse effect is a natural warming of both Earth's lower atmosphere and the surface from solar radiation being absorbed and emitted by the atmosphere. We know that sunlight is a form of radiation. It is a form of electromagnetic radiation that comes to us from the sun. But it is not the only type of electromagnetic radiation. There are many different types of electromagnetic radiation other than the light we see. Forms of radiation that we cannot see, but we can feel their effect in other ways. Now, we can see light, but we cannot see forms of electromagnetic radiation that have very high energy, higher energy than light, and we cannot see the forms that have very low energy, energy that is much lower than visible light. We can only see radiation in this very narrow range, ranging from red to violet. Now that red side, that red end of the spectrum, is the low energy end. So there's a type of radiation that's even lower than visible light called infrared, which means below red. Now that type of radiation is much lower than visible light. Then above the violets, when we go to more high energy radiation, we find what we call ultraviolet radiation. Now that also, we cannot see it, but it's much higher energy than visible light. Now, ultraviolet radiation, this high energy radiation, is often absorbed by a high level of atmosphere called the ozone. That ozone absorbs ultraviolet radiation. The infrared is absorbed at a lower level of the atmosphere by carbon dioxide. So only that visible light comes to Earth. Now, that visible light comes down to Earth from the sun, and the Earth will actually reflect that light. Now, when you think of reflection, you can think of a ball dropping. Let's say I take a football and I drop it on the ground. That football is going to bounce up. But we all understand that that ball is not going to bounce as high as my hand. If I just drop a ball, it's going to bounce, but maybe if I drop the ball here, it'll only bounce to here, because that ball has lost some energy. Now, radiation is the same way. When that radiation strikes a surface like the Earth and bounces off, it has less energy. So the Earth reflects that radiation as a low energy form. So the radiation hits the Earth as visible light, and it bounces off of the surface of the Earth as the lower energy infrared. Now, that energy, that infrared radiation, often it just escapes from our atmosphere and goes back out into outer space. But if there's more carbon dioxide in the atmosphere, more infrared radiation will be absorbed. That infrared radiation cannot escape the atmosphere, so it stays in our atmosphere. So we have more radiation and more heat, and the temperature of the Earth rises. That's known as the greenhouse effect. More carbon dioxide means more absorption of infrared radiation, which means more energy, higher temperatures. And that is the overall effect of this we call global warming. We can see an illustration of this on slide 30. That first picture in the upper right shows us the concentration of carbon dioxide in the atmosphere. Notice that from the year about 1000 to the year 1800, the concentration is pretty flat. We go up here and down there, but it stays pretty steady. It's only been since the year 1800 that that concentration of CO2 has skyrocketed. It's just taken off like a rocket. And that's largely because of carbon dioxide emissions from human activities like industry and power generation. The last image on the right side, you can see that CO2 concentration in parts per million, it tends to go up and down with the seasons, but overall the pattern is a steady increase. And it's this carbon dioxide in the atmosphere that many people think is causing changes in temperature. That's why if we look on slide 31, we see temperature variation from the year 1860 to the year about 2005. And we see what appears to be a very steady increase in temperature variation, meaning that temperatures are getting hotter every year. And not only that, but the rate at which they're getting hotter is increasing. So that about does it. We've looked at a number of effects. We've looked at a number of different types of climate. We've looked at the effect of latitude, of topography, what did we see? We saw what? Latitude, topography, of water bodies, of ocean currents, of air currents, and finally the effects that the effects of volcanoes, and finally the effects that we humans are having on the climate of the Earth. So thank you all for joining us, and we will see you again next time. Take care.